Hi, my name is Andreas. Welcome to my talk ModGuard. Back in 2016, there was quite some rumor in the Java community concerning the release of Java 9. People were afraid if it breaks their code. The reason for this was that Java 9 introduced modules. From a first sight, modules look similar to traditional jar files. They group a set of packages and resources. But modules explicitly declare their dependencies. For instance, my first module requires a module Java base to run. And modules explicitly state which packages they export. Here, my first module only exports the package myPublicAPI. All other packages are kept module internal. Together with the new module system, a feature so-called strong encapsulation was introduced. For instance, if I have a second module that requires my first module, then all classes in my second module may only access types of the exported package myPublicAPI. Any access to module internal classes is prevented by the virtual machine during compile and runtime, even if I use reflection in the second module. Given the module system and strong encapsulation, we ask ourselves, can one use strong encapsulation to confine internal data and classes within a module? And can we design a static analysis to identify and analyze unintended data flows between modules that hurt confidentiality, such that internal types, classes, methods, fields, values are exposed to the outside, or violate integrity, that internal fields, for instance, can be modified from the outside? And furthermore, we ask if real-world projects can easily benefit from migrating to modules by confining their internal types. To give an answer to this question and to the first question, we formally defined within ModGuard what constitutes an entry point of the module using the data log engine dupe, and we defined and identified two types of entry points: explicit and implicit methods. Explicit methods, on the one hand, are methods defined in exported classes in exported package that are public, protected, or static. Implicit entry points, on the other hand, are methods that are declared in exported or internal package and that become accessible as a result of the invocation of another entry point. And these methods must override or implement exported interfaces. Given this formal definition of entry point in dupe, we defined and designed an escape analysis specific for Java modules to identify escaping instances and identify confidentiality and integrity violations for modules. So which data flows in and which data may flow out of a module. To give an answer to the third question and to evaluate our analysis, we did a case study using Apache Tomcat, and therefore we migrated Tomcat to the new module system. Therefore, we migrated each jar file to a separate module using two different approaches. First, we used a naive approach using JDAPs. As a result, all modules export all their packages, and we used a second, more strict approach in which we removed all non-necessary exports from all modules, and then we analyzed each module using our analysis ModGuard. To determine which fields, methods, and classes should be considered confidential, we used the machine learning approach SUSY. Our results show that in the naive and in the strict versions quite a lot of violations still occur, and that there's not a huge difference between the strict and naive version. To summarize, can one confine internal data and classes? Partially yes. The module system prevents types from escaping, but not instances of classes. But escape analysis like ModGuard may complement the module system and allow one to reason about data flow between modules and can help one to identify unintended data flows. May real-world projects benefit from modules? Our case study shows that real-world projects may benefit, but a sophisticated migration is necessary. The high number of violations shows that a naive migration or a simple migration jar to module is not sufficient to confine internal types.